Welcome back to our class. Today we're going to be talking about the memorandum for physical science. That is paper 2, June 2025. This paper is from Limpopo province. So let's look at some of the questions which they said, and then we try to see the memorandum or how it was supposed to be done. So the first question is saying that which one of the following compound is not an ester? It is not an ester. So you need to look at what does the ester have. So let's just give an example. If you don't know the formula, an example of CH3CH2, okay, COO CH2 CH3. So just an example, something like that. That is an example of what? An ester. So how do we bring about to this concept? So let's abbreviate it. If you don't know the formula, let's abbreviate it. It's 1, it's 2, it's 3, it's 4, it's 5. Meaning that I have 5 carbons. Hydrogens is 3, it's 2, that is 5, plus 2, that is 7, plus 2, that is 10. So that is 10. And then how many oxygens? Oxygens are what? Are 2. 2 oxygens. You see that they are in, if this is 4, meaning this must be 8. If this is 2, this must be 4. You understand? Yes. If this is 10, then this must be 20. So we come here. This is 4. This is 8. This is an ester. This is 3 times 2. This is 6. Correct. Understand? Then if this is 2, 2 times 2, then it's 4, then also this is correct. So automatically, this is 3 and this is 8. It would have been 3 times 2, it would have been 6, and already 6 have been talked about here. Therefore, A becomes the most correct answer, and then C, correct. You got the next question. They're saying that which one of the following options are the 3 components arranged in increasing boiling point? Alcohol? No. This one can't be a higher boiling point than this, because this one has dipole forces, and then it also has hydrogen bonds. So this one is no. Alcohol, and then no, obviously also it's not. Then this, okay, this, then this. So the answer looks to be C. Let's look at this. This one is supposed to be here. This is supposed to be there. So the most correct answer becomes C, because of the type of bonds this one has, which does not, because this one has one side, this one has 2 sides, however much the same type of bonds, and then this one has it has no hydrogen bonds. So this one has hydrogen bonds, also this has hydrogen bonds, but this one has 2 sides. Yes, so it becomes more boiling point. So the answer is C. Which one of the following reactions can be used to prepare the ethane from octane? Since it's an alkane, so we have to break it down into smaller pieces, so automatically it becomes cracking. The molecular formula of 1,2-dichlorobutane or butane. So you need to ask yourself, what is butane? Butane is 4. So it means that I have to look for something which has 4. So I see it here and I see it here. So this one is out. But they say dichloro, 2 of them. This one has 1 chloride. This one has 2 chlorides. So the most correct answer is C. So some of them you have to use what you call elimination method if you see that unless the elimination method cannot work for you, you take off what is not correct, and then you remain with the what you suspect to be the right answer. According to the collision theory, the reaction rate increases if there is what? Increase in the temperature. The reaction rate decrease in temperature. No. Decrease in the activation energy. It looks to be correct. Decrease in concentration. Nope. Decrease in the kinetic energy of the molecule. Nope. So the answer is B. When you decrease the activation energy, you increase the rate of reaction. That's how the catalyst works. It just decreases the activation energy. All right, 1.1.6, they're saying that which one of the following statement is correct describes the characteristics of endothermic. Endothermic means that you take in heat. So if you take in heat, the enthalpy change must be positive. Yes, because it means that the product, to get a positive, remember product minus reactant. So to get a positive figure, meaning that the product must be big, while the reactant must be small, so that you are able to get a positive figure here. So let's look at it. The enthalpy change is positive, correct? The product has less energy. Nope. The enthalpy change is positive, correct? The product has more energy. It looks to be correct. Enthalpy change negative. Enthalpy change negative. No. So the B becomes the most correct answer. So you get your 2 marks there. Then we go to question 1.7. The system that is chemical equilibrium. A system is at chemical equilibrium. Which one of the following temperature of the equilibrium mixture is changed? The total number 1, total mass of the reactant and the product. The kinetic, the Kc value. Yes. The Kc value. Yes, if you look at the system of the, okay, which one of the following will change the temperature of the equilibrium mixture, will change as the temperature of equilibrium mixture is changed. Definitely it's only temperature which changes the Kc value, so that one is correct. The total mass, this one is not. Rate of the reverse reaction will change. Yes, it can change. This is also correct, meaning that whenever there is one is out. Whenever there is one is out. So this one is out. This one is out. This one is out. You see, I remain with the C. And see, you see that that's what we also gave. So the most correct answer is C. So C, 1.7C. Consider the balanced chemical equation for the following reaction. The equilibrium constant Kc for this reaction is this. And what is the equilibrium constant for the reverse reaction? So it means that it is the reciprocal of the Kc value. So I have to look for the reciprocal. That is 1. So if it is the forward is this, then the reverse is 1 out of 0.3. So I have to look for that. So the answer becomes C. Yes. Then we go to question 1.9. Which one of the following is true for acid solution at 25 degrees Celsius? It contains both. Let me clear it up. They're saying that which one of the following is true for an acid solution at 25 degrees Celsius? Okay, acidic solution. It contains both hydrozonium ion and hydroxyl ions. Yes. It contains only this. Not really. It contains only this. No, because it's acidic. It contains neither. So the most correct answer looks to be A. So A looks to be the most correct answer. So you get your 2 marks. Which one of the following is a strong acid, meaning that it can ionize completely when dissolved in water? So we know that all organic compounds are, all organic acids are weak. So this one is weak, so it's out. Group 7 acids, they tend to be strong. So this one is out, and then B, because this is hydrobromic acid. Group 7 derived from group 7 element, an acid which is derived from group 7 element. So it is the answer. It is B. So you get your 2 marks. So that is the first question. So if we can go to the second question, then we can see what is happening on the second question. Look at this question and then start to answer these questions. You need to know what is this, what is this. If you look at this, you check it here and here, and then you check this. Oh, these are the functional groups. So an alcohol, these are the functional groups. Oic acid on, that's the functional group in. So you need to know that. So since I know the functional group, what is the functional group here? This is supposed to be 1, 2, 3, 4. It's alkane. All right, let's start. Write down the alcohol. So we need to look for alcohol. What is alcohol here? We said the functional group here is here. So it is F because of this. This is a tertiary alcohol. Carboxylic acid, oic acid. We said it here. Oic. So you see now it's simple for you because you have already identified the functional groups. Then they are saying position isomer with the but2-in. 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 But1-in. Because it's just changing the position of the functional group. So it's also said it here. So it is A. Then they are saying that the product formed by hydrolysis of haloalkane. The product formed by hydrolysis of haloalkane. So when you look at it, hydrolysis, when you say hydrolysis, it means that you are going to add sodium hydroxide. So where sodium hydroxide is going to replace a halogen. For example, something like this, you replace it with OH. So it means that I'm going to be forming what you call an alcohol. So an example is this. So it means that this compound F must be the most correct answer in that regard. Unsaturated compound with the 2 or more bond between carbon atoms. So we have this and we also have this here. So it shows that it has a double bond there. And also this one, it shows it has a double bond there. So it means that it's gonna be A and F. Then we go to the next one, which is saying that a compound with a formyl functional group. Compound with formyl functional group. Formyl functional group. That is an aldehyde. So you have to look for the aldehyde. Yeah, it is here. Yeah, it is an aldehyde. So the answer here becomes G. Someone can ask G. Someone can ask that, but it's a halogen. It has a halogen. Yes, but its major functional group is that. All right. A compound with pleasant smell. Pleasant smell is that ugly smell. Pleasant. a nice smell, not ugly smell. So the answer here, we have to look for what has a sweet smell, and in most cases it's supposed to be an ester. So here is an ester. You see? Yes. So the ester is there. So the answer becomes E. So we are saying that write down the IPAC name of compound D. Compound D. Let me first clear it up. Compound D. Compound D. Compound D. Okay, they are looking for this. Okay, they are looking for this. So compound D is gonna be 1, 2, 3, 4. If I go like that side, it's also 4. So it's gonna be butane. So if it's butane, then it has 1, 2. See, if I count from this side, it's 1, 2, 3. So it's 1, 2. So it's gonna be 2-methyl. 2-methyl butane. So that is the name you're supposed to give. 2-methyl butane. Yes, so it's write down the IPAC name of F. So we are looking for F. Where is F? So F is gonna be F. It has an alcohol. So if I take this to be the longest chain, so it's gonna be 1, 2. Yes, it's gonna be 1, 2, 3. 1, 2, 3. 1, 2, 3. So it's gonna be 3. So it's gonna be, since it is 3, it's gonna be propan. But remember, if I count from 1, 2, the functional group is on carbon atom number 2. So 2, or yes, so it's gonna be propan 2, or. So, but we counted this, and this. So it has a side group. So it's gonna be 2, because it's on carbon atom number 2, 2-methyl propan 2, or. Remember, we add YL if it is a side group. We go to the next question. They're saying that compound G, we are done with compound G. Did we finish compound G? No. We're done with the compound F. So let's go to compound G. G, where is G? Is here. So let me first clear it up. Compound G, they are saying, what is it? What is the name? So first of all, we're gonna talk about that. So it's gonna be this 1, 2, 3, 4. That is butanol. Yes, butanol. But it has a side group which is 1, 2. So it's gonna be 2-bromo-butanol. 2-bromo-butanol. Yes, so you get marks. In most cases, they'll mark you here and here. Then we go to the next question. So G is done. What is H? H, we go back to H. Okay, H, they're saying that 1, 2, 3. These are 2 of them. So it's 1, 2. So basically, this is like this: CH3, CH2, C. Yes, this is a branch because there is no hydrogen here. So I'm gonna say CH3, and then down CH3. Yeah, and it shows there by the 3 there. Then CH. There is no hydrogen here, so it means that is, and then CH. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So it's like that. So now this is that. So now let's count it, or let's give it a name. 1, 2, 3, 4, 5. So it's 5. So it's C, pentane, pentan. Yeah, but the functional group is on carbon atom number 1, and there are 3 of them. I'm talking about the bonds. So it's gonna be 1 yin. Yeah. So that is the first step. Then the second step, I need to count now. Since the functional group is on this side, I'm going to say 1, 2, 3. So they are on carbon atom number 3. Therefore, it's going to be 3, 3. Because there are 2 of them, I'll say dash, di. What are they? They are methyls. Methyl, because they have 1 carbon atom. Pentane, 1 in. So it's 3, 3 dimethyl pentane, 1 in. So that is the answer for that. Then we go the next point. We are done with the H. I think we are done with H. Yes. So the next question they're asking, write down the structure formula of compound A. If you look at the compound A, we come back, we are saying that write down the structure. But this paper was fair. 1, 2, 3. They said beauty. Yes. So it is 3. Prop beauty is in. So meaning that it is double bond here. Either here or here. So it depends on. Now, the rest put hydrogens. Hydrogens, they are supposed to be 4. 1, 2, 3. 1 hydrogen. 1, 2, 3, 4. So hydrogen, 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 hydrogen. Yeah, you get it right. We go to the next question. So we get this one right. Then compound C, the structure formula of compound C, propanoic acid. Let me first clear up. Propanoic acid. So it's gonna be, prop is 3. 1, 2, 3. But they said propanoic acid. So it has an oxygen, and this, remember, this is a carboxylic acid. So that's a functional group. So now I put hydrogens to make it full. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. So it's cool. So hydrogen, 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 hydrogen. So that becomes the correct answer. Get it right. Then they go to the molecular formula of functional isomer of E. The molecular formula of functional isomer E. So I have to look for the molecular formula of functional isomer E. Where is functional isomer E? So if it is a molecular formula, it's the same thing. If this is a carboxylic an ester, then the other one is gonna be a carboxylic acid. So it's the same thing. So it's gonna be 1, 2, 3, 3, and then it's gonna be 1, 1, 2, 3, 4, 5, 6, 6, and then 2 hydrogens. Yes, so that becomes the molecular formula for that. Then they're saying that the molecular formula. Then question 2.4, they're saying that the structure formula of functional isomer of B. Structure formula of functional isomer of B. Structure formula of functional isomer of B. Oh, they are looking for the structure formula. Structure formula of functional group. Functional group of B, not functional isomer. Functional group. This is on meaning that it is a ketone. So it's supposed to be, remember ketone is supposed to be like that, of which this must be an alkyl group and that must be an alkyl group apart from hydrogen. Therefore, what we can do is to put the carbon atoms there so that we specify that it is carbon atoms which are there. So that becomes the answer. Then maybe we'll give you a tick in there. Then we go to the next question. Condensed structure formula of acid that was used to make compound E. Condensed structure formula compound E. Condensed structure formula. Compound E of an acid. Oh, here. So if this is an acid they are talking about, an ester, so it means that it's gonna be, which one is an acid? This. Because of this carbon atom without a what? A hydrogen. So that it was an acid. So if they are looking for the condensed structure formula 1, 2, so it's going to be CH3, COOH. So that was the acid, which is the ethanoic acid. Then they are saying that name of alcohol used for preparation of compound E. Name of alcohol used for preparation of compound E. Since this is the alcohol, then that alcohol is methanol. Methanol. Yes, it's one carbon atom, methanol. So it means that name the this is methanol. Then they are saying that name the functional group of G. G is an aldehyde, therefore the functional group is a formyl. Yes, is a what? Is a formyl. And then I say the homologous series to which H belongs. I go back and look for H. Where's H? Remember it has a triple bond there. So the homologous series, the homologous series, it belongs to alkynes. Yes, so that is question number 2. I hope guys you got 29 out of 29. So now it means that so far we have 20 plus 29, which makes it to be 49. So let's go to question number 3 and then we see what's happening. 5-carboxylic acid represents A to E are listed in the table below. So you have butanoic acid, hexanoic acid, octanoic acid. Learners conduct an investigation to compare the boiling points of the first 3 carboxylic acids A, B, C in the table below. Define the term what is a boiling point. These are giveaway marks. Boiling point basically is the temperature at which vapor pressure is equal to the atmospheric pressure. You want to see that the vapor pressure of a substance is equal to the atmospheric pressure. Then you'll be able to get those 2 marks. Name the main item of apparatus they used in their investigation. So state for this investigation. Name one main aim of the apparatus they used, yes, in their investigation. What did they investigate about? You're talking about the boiling point. Therefore, the main apparatus was the thermometer. It's a thermometer. Yes. State for this investigation, part A, the independent variable. What is the independent variable? So if you look at this, the independent variable, carbonic acid, okay. They're saying the independent variable is this carbonic acid, okay. ethanoic acid. But they said that the learners conducted the first three, meaning that the length of the chain. It could be the length of the chain, it could be the molecular mass, or the molecular formula. Yes. If you look at the molar mass of the substance, or molecular formula, or the chain length, all that can be independent variable. Then the dependent variable is the boiling point. Obviously, the boiling point will depend on the length of the chain or the molar mass of the chain of the compound they have decided. So state a suitable hypothesis. A suitable hypothesis. Here they want you to talk about a suitable hypothesis. So if you look at this, we see that as maybe you can say that because we want to compare the boiling point and the molar mass, then you can say that the molar mass, as the molar mass increases, the boiling point also increases. Or as the molecular mass, the molecular size or the chain length of this substance increase, the boiling point also increases. That's what we think, that as you increase the number of carbon atoms, yes, in the chain, the boiling point also increases. The boiling point of compound B is higher than that of compound A. You understand? The boiling point of compound B is higher than that of compound A. Let's go back and see compound B. Yes, is higher than that of compound A. So if you look at, both of them are carboxylic acids. Therefore, the functional group is the same, so it will not influence, because any change will not be about the functional group, because the same functional group. But the number of carbon atoms will differ, because this one is butanoic acid, the other one is hexanoic acid. So they're saying that which intermolecular force is or are responsible for this difference? The number of carbon atom is being influenced by London forces. So in this case, we can say that the answer here is London forces. Then they're saying that 3.4, which one of D or E has a higher vapor pressure at room temperature? We have to look at the compound which has a lower boiling point, therefore it will have a higher vapor pressure. So if you look at they said D and E, D. The one which is more branched is the one which has a lower boiling point. Therefore, it will have a higher vapor pressure. Therefore, E, because it has two branches, while this one has one branch, therefore E becomes the most correct answer. So, therefore, here I will say that it is E which is the answer. Refer to the intermolecular forces of D and E. Explain the answer you have said in the question above. So what am I supposed to talk about? We come back here and we see. We shall see that both of them, they have the same number of the same functional group. So what is going to be different is the branches which are there. So we can say that E, yes, E has a smaller surface area. It has a smaller surface area. Therefore, it means that it has fewer intermolecular forces of attraction. Yes, compared to D, which has a larger surface area, therefore it has more intermolecular forces of attraction. It will require more heat to break it down, so that it requires more heat to break it down, therefore the vapor pressure is gonna be low. Yeah, so E has a smaller surface area compared to D, and therefore the intermolecular forces of E is weaker. Definitely, the intermolecular force of E is what? Is weaker than and if they are weaker, therefore we shall say that it needs or it requires less heat to break or to overcome these bonds or these forces between the molecules than D. Therefore, D becomes the molecule with a higher boiling point, or this one with a low boiling point. In other words, E with a higher vapor pressure, and then D with a low vapor pressure, because the higher the boiling point, the lower the vapor pressure. So I think we are done with that. We go to question 2. So I think you got 13 out of 13. If you got 13 out of 13, congratulations. Then we go to the next question, which is question number 2. Question number 2. So on this question, they're saying that under appropriate reaction conditions, the 2-chlorobutane can be converted into but-2-in and but-2-in. Yes, but-2-in and but-2-in can be converted back to 2-chlorobutane. The flow diagram below illustrates the method. All right. Then the first question they are saying that is 2-chlorobutane a primary, secondary, or tertiary? Saying 2-chlorobutane. So I have to find out what is it. 2-chlorobutane. So it's gonna be butane is 1, 2, 3, 4, but they're saying 2-chloro. So you see that you'll find out that it is a secondary. The carbon atom with the functional group is attached to other carbon atoms. Therefore, is a secondary haloalkane. So we have said it that the carbon atom bonded to a halogen or a chloride basically is bonded to 2 other carbon atoms. Name the type of reaction that takes place in step 1. So if you look at step 1, you have 2-chlorobutane and then you have 2 but-2-ol, meaning that the chloride was replaced by OH, which we call the hydrolysis. Yes, we usually call it hydrolysis, that reaction. So the answer here is gonna be hydrolysis, or what you call substitution. Yes, you substitute this or chloride with OH, or sometimes you call it hydrolysis. They're saying that use the condensed structure formula to write down the balanced chemical equation for a reaction that takes place in number 2. If you look at reaction number 2, you have 2 butane 2, meaning that but-2-ol and then to butane-2-ol to but-2-in. So it means that I'm converting is I'm dehydrating basically. I'm dehydrating because this is a double bond and while this is an OH. So if I'm going to dehydrate, yes, if I'm going to dehydrate, therefore I have to write the equation. They're saying condensed structure formula. So meaning that I'm gonna say but-2-ol, so it's gonna be CH3 CH2 CH3 CH2, but it's but-2. Okay, it's the same thing. CH2 CH-OH. Yes, OH. Yes, it can be in brackets or not in brackets. Then they're saying but. So they are meaning that they are 4. 1, 2, no. So since they are 4, so I'm gonna make this one to be CH, CHOH, CH3, CH2, CH3. Yeah. 1, 2, 1, 2. Correct. So this one is gonna give me CH3, CH, double bond, CH, not CH2, CH, because of the double bond. Actually, the double bond is not supposed to be, because they said condensed, not supposed to be shown. It's gonna be CH3, CH, CH, CH3, then plus OH because of the dehydration which took place there. So you write this and this and this. You're not supposed to show the double bond because they say the condensed structure formula. You don't show any bond in between the molecule. They're saying that write down the reaction condition for step 1. Reaction condition for step 1. Here we say that you remember we said use it's a hydrolysis, therefore we use a strong base, or dilute strong base. It can be, for example, you can say dilute sodium hydroxide, something like that. Write down the name and the formula of the acid or catalyst used in step number 2. Step number 2, meaning that I want to dehydrate, therefore I have to apply what we call sulfuric acid. Name or formula, so we say sulfuric acid. So it's gonna be H. They said name or formula. If they say name, you don't write the formula. You have to write sulfuric acid. Write down the type of additional reaction that takes place in 3. So here, from the alkene to alkane, meaning that I'm adding a chloride. Therefore, it can be chlorination. How many do I have here? I only have one chloride, meaning that I add hydrogen chloride. So it can be hydrochlorination, meaning that I add hydrogen and chloride, so it becomes hydrochlorination, or hydrohalogenation, if you don't want to be specific to which halogen have you added. Therefore, it becomes hydrohalogenation. Yes, so that makes us to go to question number 5. When excess dilute hydrochloric acid is used, 100 grams of powder, yes, in the beaker, and in experiment, reaction rate following the reaction takes place. Okay, so here you have calcium carbonate plus hydrochloric acid give you calcium chloride plus water plus carbon dioxide. Because this is a carbonate, therefore it produces carbon dioxide and water and then a salt, which is the calcium carbonate, calcium chloride. Define what we call the limiting reagent. Is the reagent basically which finishes before when the reaction is complete, meaning that it's the reaction which is consumed completely, yes, when the reaction is when the reaction is done. So that is the one which makes the reaction to stop. Yes, excess hydrochloric acid does not influence the results, meaning that is in excess. Therefore, it will not make the reaction to stop. It's there in plenty, so it does not influence the reaction. Then they are saying that does not influence the reaction. Give a reason. So we have said that because basically we need to look at which one is, because they said is in excess. If they say is in excess, therefore it means that calcium carbonate was the one which was the limiting reagent. Therefore we say that it's because calcium carbonate is the one which is going to finish first before hydrochloric acid is being used up. They are saying that write down the amount of calcium carbonate that was produced in the first 10 seconds. They want the amount of calcium chloride that was calculate the amount of calcium carbonate that was used in the first 10 seconds. So I need to know how many. So I need to know the mass over molar mass. So because they said they want it in moles, so mass is equal to, number of moles is equal to mass over molar mass. Let me write it properly. Since they want it in moles, so it's gonna be number of moles is equal to mass over molar mass. So if I know that, therefore mass of calcium carbonate, so I need to find out what is the mass of the calcium carbonate. They said that what did they say here? They said that calcium carbonate, I need to find out the molar mass of calcium carbonate. 16 times 3 plus this plus calcium is 40. Yeah, so it's 40, so it's gonna make it 100. So meaning that the molar mass of that is going to be 100. It's gonna be 100. They said 100, not 1000. Said 100. 100. And then what is the mass of calcium carbonate? So we have to find out what is the mass of So since I started with the 31,0 and then I ended with this 30,06, therefore I need to find the difference between the two so that I'm able to get the difference, which is the mass which has been used by then. So it's 3,31,0, so it's gonna be giving me 0,4. So it means that our mass here is gonna be 0,4. So since I have 0,4 divided by 100, therefore the answer, the number of moles, is gonna be 0,004 moles. Yes, so meaning that those are the number of moles of calcium carbonate that was used by the 10th second. Write down the number of calcium chloride, the amount of calcium chloride that was produced in the first 10 seconds in this reaction. Write down the amount of calcium chloride that was produced in the first 10 seconds, meaning that the number of moles of calcium chloride that was produced in the first 10 seconds. So since this one, the mole ratio of this and this is 1 to 1, therefore is going to be the same amount, which is 0,004 moles. Yes. They didn't ask us to give whether the mass or what, they just say amount. It could be in moles or it could be in the mass, but based on the amount, the max, then I'll prefer to go with the what, with the number of moles, because it's just to relate the mole ratio. Use your answer in question above, and then what is going to happen? Calculate the rate of reaction. Let me first clear up here. They're saying that use your answer in the question above, calculate the rate of reaction at the 10th second. Remember that rate is equal to is gonna be change in the number of moles, change in change in time. So since I know the number of moles, do I know the number of moles? Yes, it was 0.004. Yeah, by the 10th second, that was it. Divided by change in time, which is 10, which is 10, change in time, which is 10 minus 0. So it gives me, even this one minus 0. So it gives me 0.0004. 04. That is moles per seconds. So that is it. When it comes to that, they're saying calculate the carbon dioxide. Now they're asking you to calculate the volume of carbon dioxide that was produced at STP in this experiment. So the volume of carbon dioxide which was produced basically is going to be equal to, let's look at let's first convert it into the number of moles, so that once I have the number of moles, I'll be able to convert the number of moles into volume over molar volume. So how much moles were produced? So in this case, I would say that number of moles of carbon dioxide, moles of carbon dioxide will be equal to the number of moles of calcium carbonate, number of moles of calcium carbonate, minus, number of moles of since when you come back here again, we look at the number of moles of calcium carbonate and the number of moles of this. There is no minus there because the number of moles are the same. Therefore, it's going to be equal to the same. So it means that, remember that we calculate the number of moles of this. Since the mole ratio is 1 to 1, therefore it means the number of moles of calcium carbonate will be equal to the number of moles of carbon dioxide which is being produced. Therefore, I will say that 0,004 moles. Yes, that is the 0,004 moles. But now I need so it will be giving me, since I said that I need the volume, therefore I'll equate the volume into number of moles. Number of moles is equal to volume over molar volume, molar volume, of which we know the molar volume, which is 22.4. It is already always there. If you don't find it there, you'll find it at the back of the equation. Yeah, it's 22 at STP. Yes, they said it at STP, which is 22.4 decimeter cubed. Divide by the volume, which I don't know, and this is equal to the number of moles, of which I have the number of moles. Therefore, I will say that number of moles, which is 0,004, yeah, is equal to volume, which I don't know, divided by the molar volume, 22.4. They cross multiply, then the number of volume, the volume of this gas produced is gonna be 0,896 decimeter cubed. So that's how we're supposed to calculate this question. Then we go to the next question. So 5.7, they're saying that when the dilute hydrochloric acid is replaced by concentrated hydrochloric acid, dilute hydrochloric acid is replaced by concentrated hydrochloric acid, the rate of reaction between this and this increases. Use the collision theory. What basically here, when you increase the concentration, you're increasing the number of particles which are reacting. Therefore, you want to increase the effective collision per unit time, and then the rate of reaction is going to increase. So if they were explaining using collision theory, you can say that when the concentration is increased, there will be more reacting particles in the same volume. You understand? We didn't change the volume, you just increase the number of particles, the concentration in the same volume. Therefore, the number of effective collision per unit time, that word per unit time, we need to see it. The number of effective collision per unit time increases, then increases the rate of reaction. So when you increase the concentration, you're increasing the number of particles which are reacting per unit time. Then we go to question number 5.8. The same experiment was repeated using the copper calcium carbonate granules. Was it powder before? Yes. Yes, the moment it was powder, it means that it was fine. The number of particles which get contact with the chemical or with hydrochloric acid, they are many. But now when they become granules, it's like swallowing food which is not grinded by the teeth, then it means that the digestion is not going to be fast. Therefore, if they are granule, then it means that the number of particles which are reacting are going to reduce, and then that is gonna make the reaction to decrease. Therefore, we shall say that how does the reaction is rate compared to the first experiment? That definitely is gonna decrease. Explain your answer. Then we can say that when the granules are used, the surface area decrease, and therefore basically the number of effective collision per unit time decreases, and then this decreases the rate of reaction. Yes, so the moment you make it granule, not powder, then the number of particles per unit time which are colliding are going to reduce, and then it is going to reduce the rate of reaction. Then we go to question 5.9. After 40 seconds, the mass of the beaker and its content remains the same. Explain what does it mean. Then it means that the reaction has reach completion, or the reaction is complete. So meaning that you look at the limiting reagent, calcium carbonate, all the calcium carbonate has been used up. Maybe all calcium carbonate has been used up, or the reaction has reached completion. That's it. Then let's look at Maxwell distribution curve. Is saying that of A is distributed molecular energies at these moles of nitrogen at STP. All right, they're saying that which graph A, B, C, D represents 4 moles of nitrogen gas at lower temperature. So they're saying that at lower temperature of nitrogen gas at lower temperature. So you have to look at here, because this it will show the concentration, and then this it will show the temperature, meaning that the one which has a heap or the maximum at the left side, it is the one which has the lower temperature. So if you draw the line there, You draw the line there, you'll find out that it is this one, so the answer becomes C. So C is the most correct answer. Which curve B, C, or D represents 0.8 of a nitrogen gas at STP? 0.8 of this. So we need to look at which one doubles, and then as at STP, meaning that there's the same temperature. Since A, they said A is showing STP, therefore the one which has the temperature which looks the kinetic energy which looks to be that of A will be the answer, because both of them are conducted at STP. So I'll draw a line going down and then going up. Straight, yes. So it means it's D, because the temperature, you see that it's the same temperature. Their peak is at the same temperature, which is STP. Yes. And then if you look at even the volume, we will see that the volume here, this is a double of that. So which shows that because here they used the 0.4, while here they use 0.8. So you have two ways in which you can use it to identify properly. Explain your answer. You can say that the kinetic energy is the same. The kinetic energy is the same, so we have seen it. We have said it here. The kinetic energy is this. We have said it is the same. So as graph A shows, the temperature is the same. The area under graph D is double. You see, it's doubled. You see, it's doubled. From here to here is half. From here to here is so it means that D is doubled. Yeah, meaning that you can say it's large enough, showing that the amount of nitrogen gas is much more larger, which means that it is doubled because of this, and the other one, the first one was 0.2. So it means that the amount of nitrogen gas which is being produced is a little bit larger. So that is it, and we get our 26 marks. Yeah, the paper was not that bad. So let's go to question number 6. So in this question, they are saying that so we need to do what you call the rice method. Yes, rice method, whereby I know now very well that rice method, it's R, it is C, it's R, it's I, it's C, it's E, and E, whereby initial concentration, that's the change, concentration at equilibrium, and then number of moles at equilibrium, and then concentration. So this is the concentration. We make them to be in brackets. So I have sulfur dioxide here, I have oxygen here, and I have sulfur trioxide here. So this is 2 based on this, and then this is 1 based on this, and then this is 2 moles based on that. Then they said that what the initial number of moles, they gave us a clue here. Therefore, I'm going to say that number of moles is equal to mass over molar mass, whereby number of moles of oxygen is going to be 40 out of 16 times 2, because oxygen is a diatomic molecule, is equal to 32 divided by out of 140, so it gives me 1,25. So it means that at the beginning, because that's what injected, for oxygen it is 1,25. This one it is 0, because it is a product, and then they say that they didn't say that it had something, and then X is the value which I don't know, which I'm looking for. So now, but they say that here that the concentration, this is the concentration. Remember, concentration, number of moles is equal to concentration times volume. Therefore, I have the number. I don't know the number of moles, but I know the concentration, I know the volume. The volume was given here. Therefore, 1,5, yes, times 0,5, which gives me 0,75. It means that those are the number of moles which were there at equilibrium. Therefore, 0,75, and this was the concentration. They talked about it. So it means that the difference between the two, I will be able to get the change, what they used. So if I subtract this from this, I will get 0,5. Yes, since now I know 0.5, what was used, that was produced, that was used, then it means that I'll be able to know using the mole ratio, which is 2, then 2 times 5 is going to give me 1. Yes, and then 2, this one is also 2. 2 times 0.5 is also gives me 1. So it means that this one 1,0 is also 1,0. Then it means that that's what was at equilibrium because it is a product, is the same thing. Therefore, 1 divided by 0,5, because of this I have to change it into decimeter cubed, so it gives me 2. So this one is already known. Now I need to know what was there at equilibrium. Yes, what was there at equilibrium, what I started with and what I used, then I'll be able to get what was there at equilibrium. So it's going to be x minus 1. Yes, and then I need to know the concentration is going to be x minus 1 over 0,5. So since I know that now, I'll come to my expression and I say that Kc of which Kc I know it, Kc is equal to but you have to first write the expression so that you're able to get those marks. Sulfur trioxide, we say that is 2 of them, so I put a 2 divided by oxygen into sulfur dioxide, they're also 2 moles. So now I replace here, I come here and I replace for 2,67, that is the what? That is the Kc they gave us, and then I equate it to this, which is equal to sulfur trioxide, which sulfur trioxide is 2 squared divided by this x minus 1 over 0.5, and then in 2 brackets of this, which is 1,5. Therefore, now I find the value of x, and I'll find out, if we place it in the calculator properly, find out that x is 1,125 moles. Yes, so that was the answer for that question. So basically it was 8 marks. So at least you get those 8 marks. Then we go to the question which requires you to interpret, identify the change made in equilibrium at T1 and T2 respectively. Okay, they're saying that identify the change that was made at temperature 1. When you come here, we see that only one increased and then this one decreased. It means that you added the concentration. The concentration of oxygen was increased, and then T2, both of them, not all of them increased at the same pace. Then it means that there was a change in the pressure. And then let me check and see, was the pressure increased or was the pressure decreased? So this is 2 plus 1, which is 3, 2 moles and 1 mole, this 3, which gives me 2. So it means that the pressure was increased. That was so that because there is the reaction did not reverse. Did you see this is a reactant, this is a reactant, product, meaning that the reaction did not change, it just shifted. Therefore, it means that there was an increase in pressure. Explain your give an explanation for your answer. Obviously, saying that increase in pressure favors the reaction that produces less number of moles. That's why I was doing these things, to find out what was actually happening, because here there are 3 before and then after it is 2. So it means that it will favor the reaction which has this number of moles. Therefore, the forward reaction is favored. Yes, as the concentration of reactant decreases, the concentration of the product definitely increases. So the forward reaction was favored. Why? Because it has less number of moles, and then that leads to decrease in the number of reactant and then increasing the number of product. They are saying that potassium dichromate is a salt that dissolves in water to establish the following equilibrium. So we have this equilibrium. Chromate, hydrochloric acid, and then this is dichromate, then H2O, then chromate, and then an acid. So it's orange to yellow. Explain what is meant by closed system that applies to chemical equilibrium. It's a system which is isolated from the surrounding, basically. You must be closed. It's closed, it's isolated from the surrounding. Sodium hydroxide is added to the orange solution. What is the observation upon the addition? When you add sodium hydroxide, yes, basically it's a strong base. It's going to ionize to produce these hydrogen ions. So the hydrogen ions are going, hydroxyl ions are going to react with the hydrogen ions, making now less number of hydrogen ions. Therefore, the forward reaction is gonna be favored. Then it means that the reaction is gonna turn yellow. So explain your answer. The sodium hydroxide react with hydrochloric acid or with the HCl, with the hydrozonium ions or the hydrogen ions, yes, which reduces its concentration, and then this will favor the forward reaction. Then the concentration of chromate, the concentration of dichromate decrease while the concentration of chromate increases, and then it turns from orange to yellow. That's it. Then question number 7, define the term acid. Acid is a proton donor based on Rory. It's a proton donor. Then they are saying that 3,65 grams of hydrochloric acid react with the 200 cubic centimeter of dilute hydrochloric acid to prepare an acid solution. The final temperature of the mixture is this. The balance equation is okay, it's placed. They're saying that hydrochloric acid plus water gives you chloride ions plus hydrozonium ions. Write down the conjugate base pair of this reaction. If this is an acid, yes, an acid, then therefore this is a base. So this is, let me just write it. Hydrochloric acid plus H2O gives you chloride ion plus hydrozonium ion. So if this is acid 1, therefore this is going to be base 1. And then if this is acid 2, remember it is plus acid 2, therefore this is going to be base 2. So I think now it's this, and then this, and that. So it must be that way. Hydrochloric acid and hydrochloric acid and chloride ions, and then water and hydrozonium ions. What is an amphoteric? Is a substance that can act as an acid or a base. Yes, it can react with both acids and bases. So that's it. Write down the formula of the substance in reaction given above, which act as an amphoteric. It's water molecule. It can act as a acid or it can act as a what? As a base. Yes. Identify the substance. They said the formula, meaning that don't write water. If you wrote water is wrong. Yes. Identify the substance in the reaction that gives the solution its acidity. What gives the substance its acidity? Identify the substance. Yes. That gives the solution is acidity is because of this hydrozonium ion, because it is what? It is an acid, so it is giving it, but it is a weak one. Calculate the concentration of hydrochloric acid produced. They want the concentration of hydrochloric acid produced. So it means that the concentration, remember number of moles is called concentration times volume. Do I have volume? No. Do I have the volume? Yeah, concentration times volume, isn't it? Yes. So meaning that I have the volume. So which is also equivalent, if I say that number of moles is equal to concentration times volume, which is also equal to number of moles is equal to mass over molar mass. So basically it means that volume is equal to mass over molar mass, which is equal to number of moles. So since I know that, therefore I can say that number of moles is equal to mass over molar mass. So since I know my volume, I'll multiply it by the molar volume. Therefore, it's going to be number of moles, which gives me number of moles, which I don't know, is equal to mass, which is 3, they gave me the 3.65 divided by mass, which molar mass, hydrochloric acid chloride is 35.5, then plus 1, which is for hydrogen, which is 36.5, times the volume in decimeter cubed, which is equal to 0.2. Yes, because I have to divide by 1,000 to make it decimeter cubed. Therefore, the number of moles are going to be equal to 0.02 moles per decimeter cubed. Number of moles per decimeter cubed. That's why I divided it by this volume, which is 1,000. Yeah, it could be number of moles, but this is number of moles per decimeter cubed. Yes, because why? Because they want the concentration of that. Yes. Actually, this is not number of moles, these are concentration. Yes. Calculate pH of HCl. pH of HCl, remember pH is equal to negative log of hydrogen concentration. Therefore, I'm going to say that pH of this is going to be, let me just clear it up. The pH of this, okay, wait. The pH of this is going to be, pH is equal to negative log of hydrozonium ions, whereby I have the concentration. Yes, I have the concentration already. Therefore, I will say that the pH is going to be equal to negative log of 0.02. Yes, those are moles per decimeter cubed, which we calculated just above as the concentration, which gives me 1.699. So that is the pH. Then we go to the next question. 1.6 of pure magnesium carbonate are dissolved completely to in 39 cubic centimeter of nitric acid. And then they are saying that the equation of, took place. They're saying that magnesium carbonate and nitric acid, magnesium nitrate, giving you plus carbon dioxide plus water. Excess hydrochloric acid exactly neutralize this, and then of the same neutralize this, and then 15 cubic centimeter of the same sodium hydroxide neutralized by 12 cubic centimeter of initial nitric acid. Excess HCl neutralizes exactly this of sodium hydroxide. 15 cubic centimeter of the same sodium hydroxide solution neutralized by 12 of Okay, let me first read that question. Why putting two acids at the same time? All right, they're saying that write down the balanced equation of the reaction of sodium hydroxide with nitric acid. Remember, this is a base and acid, strong base, sodium hydroxide plus, did they say HCl? Nitric acid. Why am I rubbing off? Nitric acid giving me is you form a salt and water. Sodium nitrate plus H2O. Yeah, since it's single bond, then it means that the number of everything is this is liquid, this is aqueous, and this is a solid. Yeah, that's it. Then we go to the next question. What are they saying? They are saying that write down. Okay, we are done with that. Calculate. They're saying calculate the concentration of the initial sodium initial solution of nitric acid. All right, let me first clear it up. They are saying that we need to sort it out. Calculate the initial. Calculate the concentration of original nitric acid. Okay, they want the original solution of nitric acid. So what I'm going to do is I need to first find out how many moles, because I know too much of this, how many moles, so that from there I'll be able to equate it to nitric acid. Yes, so that I'm able to get those number of moles. All right. Remember that number of moles is equal to mass over molar mass. Yes, of which number of moles of what? Of calcium carbonate, because magnesium carbonate, not calcium carbonate, magnesium carbonate. This is magnesium carbonate. Yes. Is gonna be equal to number of moles. It's gonna be equal to mass. We have the mass here, which is 1,68 divided by magnesium. So magnesium 16 times 3 plus 12 plus, so it gives me 84, the molar mass of magnesium carbonate. So this gives me 0,02 moles. These are the number of moles of magnesium carbonate that was dissolved in 39 cubic centimeters. Okay, now since I know that, now I can go to mole ratio of magnesium carbonate to not hydrochloric acid, nitric acid, of which it is 1 to 2. It's 1 to 2, meaning that the number of moles of nitric acid is gonna be equal to 0,02 times 2, which gives me 0,04 moles. So yes, now since I know the number of moles, let me draw a line here. Since I know the number of moles, now I need to know the concentration of the acid. The concentration of what? Of the acid. Remember, still, number of moles is equal to concentration times volume, isn't it? But what am I looking for? I'm looking for the concentration. Therefore, it's gonna be concentration is gonna be equal to number of moles times over volume. Do I know the concentration? I don't know the concentration. You understand? It's equal to number of moles over volume. Do I have the volume? Yes, I have the volume. They gave it to me here. So it is 39. Therefore, I divide it by 1,000. Therefore, it's going to be 0,0. It's going to be 0,039. Do you understand? Yes. So if I cross multiply, yes, my concentration is going to be equal to X is going to be equal to, no. My concentration, is it my concentration? My number of moles is going to be equal to 0,039x. That is the initial number of moles. You understand? That is the initial number of moles. So now from there, it's we go to the next step. By relating, let's look at the mole ratio of, because now I need now to compare. This with the nitric acid. Yes. So I'm gonna say that the number of moles of sodium hydroxide to nitric acid is gonna be 1 to 1, because based on the equation which we wrote, it is 1 to 1. So since now I know that, what is the number of moles of sodium hydroxide which was dissolved in 15 cubic centimeters? Yes. What was the number of moles? Yes. Number of moles of sodium hydroxide. Yes. That was dissolved in 15 cubic centimeters. We go back and find out. They said here, the same solution utilized 12 cubic centimeters, isn't it? Yes. So remember the one which we calculated was in 12 cubic centimeters of nitric acid. So it means that since they say that 15 cubic centimeter of the same sodium hydroxide neutralized 12 cubic centimeter of nitric acid, then therefore it means that if the number of moles of nitric acid, yes, if the number of moles of nitric acid was 0, where is it? We need to find it out. Yeah, here. If this was a number of moles of nitric acid in 39, therefore it means that in 12 it will be number of moles will be 0.01 2x, because I don't know the initial, but this in 12 cubic centimeter. If in 39 was this, therefore in 12 it will be like this. Therefore, if it is in 12 for nitric acid is this, and this the 12 which reacted with this 12, yes, reacted with the 15. Yeah, therefore it means that it's the same number of moles which reacted with the sodium hydroxide. Therefore, the number of moles of sodium hydroxide are going to be what? Are going to be the same in the 15 cubic centimeter, because 15 cubic centimeter of nitric acid of sodium hydroxide reacted with the 12 cubic centimeter of nitric acid, and the mole ratio is what? Is the same. Therefore, the number of moles are going to be the same. Yeah, so now since I know that, therefore I will know that the number of moles, so my concentration is gonna be equal to number of moles is of I'm looking now for sodium hydroxide is equal to number of moles over volume, whereby number of moles I know that 0.012x divided by the volume, which is 0.015, because it is 15 cubic centimeter and then divided by 1,000. 15 cubic centimeter divided by 1,000, so it gives me 0.015. Therefore, it means that the concentration of sodium hydroxide is gonna be equal to 0.8x. Yes. Then now, since now I know that, I can now know what is there in 25 cubic centimeters. So in 25 cubic centimeters of sodium hydroxide, yes, in 25 cubic centimeter of sodium hydroxide, which they mentioned here, yes, yes, I'll be able to know. I just multiply it, and I'll say that is 0.8x times 25, whereby 25 divided by 1,000, which is 0.025. So it means that the number of moles of the concentration of sodium hydroxide in 25 cubic centimeters, yes, is gonna be equal to 0.02. That is x. Our x is still there, is being carried out. Yes, that was the number of that's the concentration of sodium hydroxide in what? In 25 cubic centimeters. But remember, hydrochloric acid was in excess. So if hydrochloric acid was in excess, yes, since they have the same number of moles, therefore it means that that was the hydrochloric acid which was, since this is the same number of moles, sodium hydroxide, so it is equal to the number of hydrochloric acid which was in excess. Did they use hydrochloric acid? The number of nitric acid, not hydrochloric acid. I don't know, because I'm used to this nitric acid, not hydrochloric acid. This was a mistake. It was a mistake. It was not supposed to be hydrochloric acid. It was supposed to be nitric acid. Therefore, we will say that the number of moles of nitric acid, number of moles of nitric acid in excess is gonna be equal to 0.02x. So since now I know the number of moles of nitric acid in excess, therefore now I can now calculate the rest. The number of moles of nitric acid which reacted with the magnesium chloride, I have to subtract by the number of moles of magnesium carbonate, yes, which reacted, and which is equal to is gonna be equal to 0.039x, which we calculated here at the beginning. Yes, which we calculated here at the beginning. You see it here. Yes. Minus 0.02x. You understand? Then it gives me 0.019x. So now since 9x, then I have to equate it. To the number of moles, which we calculated here, yes, of which we calculated there. Therefore is equal to 0.04. So now since from there I will be able to calculate my x, whereby x is gonna be equal to, if I divide, therefore is gonna be equal to 2.11. Therefore the number of the concentration of nitric acid, yes, is equal to 2.11 moles per decimeter cubed. Or sometimes we can say 2.11 molar, capital M. Yes, so moles per decimeter cubed is the same as saying molar. I think, guys, that is it. The paper was not that difficult. It was a little bit fair. So I wish you the best, guys, to the people who are writing for Gauteng. The best for your incoming paper. Thank you so much. See you again in the next